Hello everyone, this is Dilleswara Rao from Aeronautical department. Um, so last class we have making continuation on derivation of equations for longitudinal stability derivatives. So we are on the way to continue that derivation. So the last class we have derived the stability derivatives for linear direction and the z direction derivatives we have derived. So now we will do the angular momentum derivatives and its derivation also we will continue today. So we already said that the derivation of equation of motions for aircraft will represent the mathematical representation of mathematical representation of aircraft motion. So to this derivation is for making that like we need to make this aircraft motion in a mathematical representation. We need to get the stability derivative values also. These stability derivatives need to be need to understand its variation and its effectiveness also. So generally, we said like in wind tunnel testing of any aircraft before if it is going for a full scale model, we need to define the stability derivatives behavior in with respect to the flow velocities in a linear direction and a lateral direction also. So on that way, how these derivatives are significant, that we will see it completely. So as of now, we are talking with the control system design only. So the control system design may be mostly depend on the instrumentation and its logical behavior, but this instrumentation also depend on the formulation of the mathematical model. So let's see how these derivatives are effective for different condition. So yesterday we have, last class we have did the derivatives for linear direction, that is CZ, CXA and CXZ. So those two derivatives we already did. So now we will see CMA and CMZ. So let's go into the topic. So first we will start with the tail, the wing root derivation, like around the wing, how that flow is being going on. So also here we already discussed about the downwash on wing surface also, like downwash, how it is happening due to the pressure, due to the flow separation over the airfoil. So if the flow separation is there over the airfoil and if it is continue over the wing, so what it will happen? The lower pressure and higher pressure will get mix at the wing tip. So after mixing of the two pressures, it will create a vertices around that wing. So that vertices will continue over that. It won't be stop at. It won't be stop at wing tip only. It will continue till tail surface also. So due to that, the abrupt downward velocity will be there will be a rapid change of downward velocity, that is called as a downwash. So the downwash means the downward component of velocity is getting increasing time to time due to this wingtip vortices. So due to that effect, that the downward component of velocity and with the linear change in the linear velocity component u also, how these stability derivatives are being effective, and how these stability derivatives are changed with respect to this downwash component velocities w naught and linear velocity components u naught, and with respect to the x direction and z direction. So on that way, this stability derivatives we denoted with the C. So how it has been changing. So we discussed about CZ, CF, sorry, CX alpha and CX U and CXU, I mean, with respect to U, and CXZ with respect to Z also, we have derived the stability derivatives. So now we will see CMU and CMZ. So CMU, let's talk about CMU. So it is a stability derivative, that is a moment with a moment derivative with respect to the velocity change, linear velocity change. So this is the change in pitching moment due to that change in forward velocity. So the term permanently results of spill stream effect. That is like a spill stream effect means what? So due to the linear velocity changes, how that how the stability things also getting affected. So the aircraft flexibility and complex compressibility also will affect by this term. So and generally in transionic region, like we said, greater than zero point 0.8. So M is zero point 0.8. So the static stability of aircraft can be vary considerably. So below the transionic region, that means less than the Mach zero point 0.8, less than Mach zero point 0.8. The CMU can be safely neglected for the jets. The changes in CMU are due to the shift and usually rearward of the center of pressure, and that center of pressure shifting from rearward to forward as the aircraft enters into the transit region, so that the CM will gets negative values. So the CM means what? The moment coefficient, moment derivative with respect to the change in velocity u. So that is we given with CMU. So these will get negative values when that aircraft aerodynamic center of pressure is being changing from backward direction to forward direction due to the change in this velocity. And CXA is the change in force in x direction. This is again a force. Stability derivative with respect to the x direction force. So this is a change with respect to the x direction due to the change in alpha caused by the downward velocity change, that is W. Okay, so here you see for the wing section how the forces have been located. So see here the lift force is acting on upward, and the downward direction weight is acting. So that is in j direction. So anyway, the thrust and drag also will affect. Thrust and drag force will act opposite direction. So this alpha is actually the actual velocity, this thrust velocity with thrust vector velocity to that wing chord we've given with the alpha, and there is a change in this alpha will be given with alpha prime. So that is with respect to the with respect to the uh, velocity direction u, that x direction to the thrust velocity vector w, because we already discussed this also. The thrust vector and w d may not be having inline. There will be some angle also will be there in between. So because of this, aircraft axis are fixed with the aircraft, like a body axis or body axis system is fixed with aircraft incidence. So the disturbance resulting in a vertical velocity produces a lift and drag vectors that are no longer be perpendicular to each perpendicular and parallel to x-axis. Yeah, as we said, no. So these forces may not be totally perpendicular with the body axis system. There will be some angular because of this velocity changes only, and the orientation changes also. The forces may not be acting always in direction with the body axis. So that to find the contributions of lift and drag in x direction. So what are the forces acting on the x direction will be like what? So you see here, previously we said the here the this is the thrust vector direction, and this is the drag direction, and this is the x direction x axis direction. So this is having a if you prolong this one, so this is also alpha prime only. So this is at an angle alpha prime with the d. Then what are the velocity components? So that will be the d cos. The effects with respect to x, what are the forces? So drag force is d cos alpha, and lift force will be l sin alpha, like sin alpha prime. So because this is a lift, and this is at an angle alpha with this one. So this if you want to make this as a if you want to make this as a component, so this will be cos component and this will be sine component. So that sine component will be in positive direction and the drag is negative direction. So that is why L sin alpha prime minus d cos alpha prime. So if you differentiate with respect to this d, with respect to alpha, the dou f by dou x. So what it will be? So dou L by dou alpha prime. The sin alpha prime plus if you make this as a sin theta will be cos theta. So that will be L cos alpha prime minus same for a d also, dou d by dou alpha prime cos alpha prime plus should be plus cos alpha will give minus sin alpha, so d sin alpha prime. So this will be like if you multiply with the minus, so this will be like minus of minus, it will be plus. So the total equation will be dou L by dou alpha prime is equal, dou L by dou alpha into sin alpha prime plus L cos alpha prime minus dou d by dou alpha prime cos alpha prime plus d sin alpha prime. So if it is at angle if alpha is 0, like if it is alpha angle is that angle is 0, because if you assume that that is almost identical with the x direction, so then it will be like what, sin 0 will be it is 0 only, so this term will be 0. So here cos 0 will be 1, so that L. So dou d by dou alpha prime will be having, because here also it will be 1 only. So that will be L minus dou d by dou alpha prime. So that will be equal to L minus, we can say if it is a total, alpha is a function of alpha prime. So then it will be like what, dou alpha prime by dou alpha will be taken as 1. So the total thing will be like what, L minus dou d by dou alpha. Okay, so now if you multiply this like cx a, we already made it with 1 by s cube. So if you multiply with 1 by s cube with this one, so what it will be? So 1 by s cube into dou alpha by dou fx by dou alpha. So that will be equal to what? If you are making it with this thing again, if you make this fx in terms of L, so what is L? L it will be, so L will be half rho v square SCL. So SCL. So how again Q will be what? Half rho v square. So then this will be like what? L by SQ will be, so here half rho v square, also rho v square, and SQ is there, so SS gets cancelled, so CL will be there, and here it is there, and D will be like what? So D will be half rho v square S CD. So if half rho v square S CD, then dou D by dou alpha will be what? Half rho v square S dou CD by dou alpha. So this is the case. So again it will be divided with 1 by 1 by SQ. So SQ is again half rho v square. So half rho v square, this S will get cancelled, so that dou CD by dou alpha will be there. So the total equation will be what? Cxa will be equal to 1 by SQ into dou alpha, dou fx by dou alpha. So that will be equal to CD minus dou CD by dou alpha. Okay, so this is for CXA. And then CZA, like same thing in Z direction. For the same notation only, if it is in Z direction, what will be the force equation? So again, the z direction values also we have given here now. So what is this one? So this is in a reverse direction, and this will be alpha prime. So this component will be like what, L cos alpha. So that will be like a reverse direction. So minus L cos alpha minus d sin alpha, because sin alpha is in this direction. So the drag force component also in the same direction. So that will be minus L cos alpha minus L minus the sin alpha. So again, do with respect to alpha prime, if you make the differentiation, so same thing we will get it from previous equation only, like a dou L by dou alpha prime cos alpha prime plus a L sin alpha prime minus a dou CD by dou alpha prime into sin alpha prime minus d cos alpha prime. So again, at alpha equal to 0, I mean alpha prime will equal to 0, and alpha is a function of alpha prime. So then what it will happen, again we will get dou alpha by dou L by dou alpha minus here d only. So again we will get minus dou alpha minus dou L by dou alpha minus d. So again if you are multiplying with 1 by sq and substituting L equal to half rho v square SCD SCL, and d equal to half rho v square SCD. So if you multiply this one, so again we will get minus CD minus dou CL by dou alpha. So that will be identically equal to dou CL by because drag coefficient in z direction is very less. So the coefficient we will get it is minus dou CL by dou alpha. So for the CZA and CXA, so CXA and CZA we got here, right? So this is for CXA and this is for CZA. And the next one will be like momentum coefficients, like Cm alpha and Cmz. So Cm alpha is a change in pitching moment due to the change in angle of attack. So this term determines the static longitudinal stability of aircraft and must be negative for a statically stable aircraft. So a statically stable aircraft is one that tends to return to its equilibrium position after a disturbance is occurred in this one. So a negative Cm alpha, as we said, due to that downward component, the center of pressure is transferring from backward direction to forward direction. So it is getting negative values. So the negative Cm alpha means that the angle of attack increases positively, then the pitching moment becomes negative. So tending to decrease the angle of attack, the opposite values will comes to the Cm alpha. This is the wing, and if it is an angle of attack, so if it is an angle of attack is there, so that the momentum will be acting like that, so that Cm alpha will get negative values. So if this angle of attack is decreasing, so it will get positive momentum, so that Cm alpha will get positive values. So same like that Cm alpha, how it will be like that CL and the CD derivation with respect to alpha we did now. So same for that case only, that Cm in terms of CL, if you take a Cm, then the derivation will be like what, dou Cm by dou alpha. So this is in terms of it will be changes with respect to delta and alpha. So that will be like dou Cm by dou CL into dou CL by dou alpha, because Cm is a function of CL and CL is a function of alpha. So if we take the total derivatives, then dou Cm by dCm by dCl into dCl by d alpha. So the dCm by dCl will be the change in Cm with respect to that CL for an aircraft A with the elevator fix. That is like elevator fix means that elevator angle of attack is delta. If it is 0, that means elevator is neutral position. So then we need to change. We need to get the values of CMA with respect to CL changes only. But though DCM by DCL is the same as that static margin, that is under DCM by DCL by equal to SMQ. So this is a relation we will get it from that margin level things and design level things only. And next, that if you talk about the static margin, so static margin will be equal to x by c. So x will be the change in that x position on the chord. The position of the thing in the chord, like what? So if it is a airfoil, and this x position will be changes, and this total will be chord. So where x is the distance between the fixed control neutral point and center of gravity of the aircraft, and c is the main aerodynamic chord. So that mac we already discussed last class also. Mean aerodynamic chord is like what? So generally quarter chord level only this aerodynamic center will be aerodynamic center will be situated. So from there only all the forces and moments we will generally taken care. So the center of pressure will changes from backward to forward and forward to backward due to this forces acting on that one. So if the center of gravity is ahead of the fixed control neutral point, so fixed control neutral point is if it is here, if center of pressure is ahead of this one, so then the x is negative and the aircraft is stable, because the center of pressure is in a forward direction. So if it is will be in a stable condition. If the location of center of gravity for which the static margin is zero, or the point at which DCM will be, uh, at a point like if the axis exactly matches with this control neutral point, so then there the angle of attack is zero only, because there is no pitching moment on this one. This will be in a stable condition, so that the CM alpha with respect to change in alpha will be equal to zero. So then CM alpha will be equal to SM, that the static margin at delta, into DCL by D alpha. So DCL by DCM by DCL, we make it as a static margin. So that the CM alpha will consider like it. So the CM alpha is the effect of rate of change of angle of attack caused by W naught on the pitching moment of motion. So the change in angle of attack on the tail due to the rate of change of downwash is given by dou epsilon by dt into delta t. So this already we have discussed in last video. So how this change in angle of attack with respect to the time change and the rate of change of downwash also, how it is how we have considered. So that is like d epsilon by dt into delta t. So it's like a total derivative term. So like delta t, you can take it as a lt by u, like we said, no. So u is what? LT by T. So the T will be like what? LT by U. So if it is delta T by LT by U, then delta alpha T will be what? D epsilon by D alpha T, d alpha t, and the d alpha by dt into lt by t. So then that equation totally we can write it like d epsilon by dt into lt by u into alpha dot. So d alpha by dt we can write it as a d alpha dot. So the d delta alpha t by d alpha dot will be equal to, so d epsilon by d alpha into lt by u. So here the dou cm by dou alpha, again we make it like dcm by di, like angle of incident, and with respect to d alpha by d alpha t by d alpha dot also, where this dcm by di at t is the rate of change of pitching moment coefficient of the tail with respect to the angle of incidence, and alpha delta are the elevated deflection at constant values. So then that CM alpha will be like what? 2u by this CM alpha we already taken in a previous thing, like previously in starting videos on derivation of equation of motions. So there we have given a list of stability derivatives used for this equation of motion. So there we define this CM alpha is like what? 1 by SQC, one in terms of dm by d alpha prime. So we have defined like that. So that will be like what? 1 by SQC into 2u by C into dm d capital M by d alpha prime. So here M is what? So SQC into CM. So CM is the constant that moment coefficient. S is like span area, the C is the chord, and half rho v square S cm c. So that will be like half rho v square is a q, like a pressure force into the span area. So the span area will be like a force only. So force into the distance, like for the perpendicular force into distance will be like what, the moment only. So this whole term will be like that force into distance. I mean distance term. So that the same will be the coefficient of momentum. So if you substitute in terms of in terms in dou m by dou l, like what, sqc cm by dou alpha dot. So then it will be like what? So that SQC will be taken out. So 1 by SQC into 2U by C into SQC into dou CM by dou alpha prime. So the dou CM by dou alpha prime. So again SQC and SQC and these things will be gets cancelled. So we will get 2 into dou CM by dou alpha. This will be gets cancelled, and 2u by c will be there. So 2u by c will be like what? So 2 into dou cm by dou di into d epsilon by dt. So like what? I mean, in terms of this one, what is the what is the left term? Left term is this one. So that will be de by dt into lt by the u will be gets cancelled and c will be there. So like what? I mean, if you are gets confused, like what it will be, 1 by sqc into 2u by c into sqc into dou cm by dou alpha dot into d delta alpha t by d alpha dot, that is the alpha dot. So then it will be like what? 1 by sqc into 2u by c into sqc into dou cm by dou alpha dot. Dou alpha dot again we have written in terms of di, and d alpha d into delta alpha t by dt will be like what, d epsilon by dt into lt by u. So if this uu gets cancelled and this sqc and sqc gets cancelled, then what is the remaining term? So cm alpha will be equal to, so 2 into dou cm by the di of t, and d epsilon by d alpha into lt by c. So that is the leftover term. So that only we have written here. So here for cm alpha dot also we got expression for that. So the next thing, if you want to express that in this thing, so like you see here, so this is the aerodynamic center, and if it is in linear direction and jet direction, so the incident angle of attack will be d alpha t, and here the incident lt into theta dot, and this is been I mean, if it is a tail direction, so that the length of this also we have given here. So here the d epsilon by d alpha will be equal to, so 2 by pi a r into dcl by d alpha for w. So these are also the stability equations from the stability derivative terms only. We have directly considered this one. So the cxa, from this cza, sorry, cza, if you want to find out. So what is cza? That means that jet direction effect, if you want to make it. So cza is the effect of rate of change of angle of attack caused by the w naught term. Like the w naught is what, the downward velocity components due to the jet force. So this derivative arises from same cause as cm alpha, and can be derived from cm alpha dot, and by dividing and substituting the length lt obtained by the force coefficient from a movement coefficient. So that length is lt. If you substitute on that, so what it will be, that cz alpha will be like what, C by LT into CM alpha. So if you do again the CM alpha from the previous thing, what it is there. So so that will be like what again the CM alpha will be C by LT into 2 2 into DCM by DI into D epsilon by D alpha into LT by U. This 2 by LT by C we already got, no? So this C there gets cancelled and LT gets cancelled. So that leftover term will be 2 into dCm by d alpha, sorry, di into t epsilon by d alpha. So these are the leftover terms. So here the Cm again that Cm alpha will be the effect of rate of change. The pitching moment change with respect to that rate of change. With respect to the x direction. So this is from the curvature of the flight path and which causes the angle of attack of the tail. So the aircraft has a pitching velocity and tail will have a vertical velocity component equal to LT theta. So the velocity and u we can write it like a V RES, and the rate of change of angle of attack resulting from pitching moment can be expressed as delta alpha t. That will be like d alpha t. We already derived with dt we have given like nt by u. So the dt is in terms of d alpha t. So that that lt we can write it like lt into theta dot. So that theta dot lt theta dot by u will be the d alpha t. So the d alpha t, if you derive that one, so what it will be? So again, if you with respect to d theta, if you do the with respect to d theta, if you do the differentiation, so that LT by U only will be there. So again, the d Cm by d theta t will be like what? Again, do that. What is there? So d Cm by di alpha into d alpha by d theta, that will be equal to dCm by di into LT by t. So that CMQ, with respect to that Q will be like what? This CMQ expression also we have defined in terms of capital M in a previous derivative, like stability derivative list we have given now. So that is like what? So again, 1 by SQC into 2U by C into dou capital M by dou theta. So again, M will be equal to what? SQC into CM. So if you substitute that one, what here it will be like 2k into dCm by di into LT by C will we get. So here the k is the rough allowance of for the contribution of rest of the aircraft CMQ, and this is usually at 1.1 level only. So for the swept wing, the this value will be changes. The same as for CZQ also. So CZQ is what? C by LT into CMQ. So CMQ is already we got. So that will be like what? 2k into dCm by di into alpha t at t. So this is for CZQ. So here the CZQ is the change in the jet force due to the pitching velocity. As the case CZQ, the stability derivative can be derived from the CMQ by multiplying with C by LT. So that CZQ will be C by LT into CMQ. So that CMQ we already defined previously. So that CZQ and CZ alpha are often neglected in the final equation of motion, because this is not from the fact that these terms are negligible in comparison with other stability derivatives, but from the fact that they are negligible when combined with other terms, which forms coefficients of alpha dot and q respectively. So then what finally we will have C by 2U into CZ alpha is very much less than MU by SQ. So then, so C by 2U into CZ Q also very much less than MU by SQ. So the relative magnitudes of these terms will be checked for any particular stability derivatives and flight conditions also. Like if these terms are making in practical, available variables, so that is mu by s cube. So if you make it in like this, so then that CMA is the effect in pitching moment resulting from moment of some external force, and this is in this case those follow elevator for an aircraft conventional elevator. So the CM A will be like what CM delta E into delta E. This delta E is the elevator angle of attack. So where CM delta is the elevator effectiveness. So that is again that moment coefficient only. So then it can be write it like CMA will be equal to CM IT and the delta IT. So that will be equal to dCm by di into delta IT. Like again we are making that derivations where differentiation with incidence angle Ti, and CFZA will be write it like Cz delta E into delta E, and Cz delta E we can write it like 1 C by Le into Cm delta E into Cm delta E into delta E. So CFXA is the effect of force in x direction due to the deflection of elevator. So this will be the effect of force with respect to the elevator deflection. So this is the change in drag due to that elevator deflection and is usually neglected because that force is compared with uh, elevator forces compared with wing forces are very less only. So these effects will be generally for a long aircraft, full scale aircraft, this will be neglected. But that doesn't mean that this is not useful for making that stability constraints for an aircraft. So these are all required only, but how this requirement is there for each and every aircraft, like like we said, no, that velocity variations in linear direction. So for the longitudinal equations, only the effect of elevator has been considered. So that gear, flaps, and drive brakes are also changes in forces and moments, and that will be appear on right hand side of the equations along with the CMA, CFZA, and CFXA. So these are all we consider with elevator effectiveness. But even though small forces also, how that has been affect the aircraft stability. So for that condition only we have derived all these things. So like from the starting you see CXA, CZA, and CMA, and CMQ, and CFZA, and CFXA. So these are all stability derivatives with respect to wing and with respect to the tail part also. Both the effectiveness we have considered here. So in addition to that, there will be like flaps, brakes, and gear changing and forces movements. Small perturbation movements also. That effective forces also we need to be considered. So by considering all these things only, we can say that the aircraft stability is how we can get the aircraft stability in a static region. So this is all about aircraft equations of motion in longitudinal direction. So longitudinal equations of motion and longitudinal stability derivatives also we have discussed here. So this is all about the mathematical representation of this stability of derivative. So in coming classes we will see some advanced topics on control systems much more effective. Okay, thank you.
Like, share, and subscribe. Hit the bell icon for more updates.